morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are continuing our discussion on double angle formulae. So this is part 2. The great Neil Diamond coming to America. We are coming to mathematics, specifically some trigonometry. Let's get to it, shall we? Back to Neil in a little bit. All right, just a couple of examples here. If alpha is acute and cosine 2 alpha is equal to 3/4, find the exact values of cosine alpha and sine alpha. Let's get to it, all right? Well, I know that cosine of 2 alpha equals a lot of things, okay? I'm going to choose it. It doesn't matter really. I'm gonna use different ones here. So that's going to be 2 cosine squared alpha minus 1 using this double angle formula. So I know the value of cosine 2 alpha is equal to 3/4. So I replace this with 3/4. So that is equal to 2 cosine squared alpha minus 1. If I add 1 to both sides, I get 1 3/4, which is, well, let's just go ahead and write it. 1 3/4 is equal to 2 cosine squared alpha. Divide by 4, this is 7/4 equals 2 cosine squared alpha. It's easier to deal with. I divide by 2, I get 7/8 equals cosine squared alpha. So plus or minus square root of 7/8 is equal to cosine alpha. Now remember, they said find the value of cosine alpha, not alpha. So I'm almost done, except we know that alpha is acute. And if alpha is acute, that means it's somewhere between 0 and pi/2. Well, cosine is positive here. So that means that our final solution here would be cosine alpha equals the square root of 7/8. Booyah! Okay. We could simplify that square root of 8, I guess. Let's go ahead and do that. So that could be square root 7 over square root 8, which is equal to square root 7 over 2 root 2. Which is fine. We could rationalize the denominator. Any of these really are fine. Actually, this one or this one. I just wanted to make sure you remembered how to rationalize the denominator. All right, let's find sine alpha. Okay. Well, I know that sine squared alpha plus cosine squared alpha is equal to 1, which means that sine squared alpha is equal to 1 minus cosine squared alpha. So sine of alpha is equal to plus or minus the square root of 1 minus cosine squared alpha. Well, I know what cosine alpha is. It's a square root of 7/8. So sine of alpha is going to equal plus or minus the square root of 1 minus root 7, well, let's make it one big square root, sorry. So root 7/8 squared. So sine alpha is equal to plus or minus square root of 1 minus 7/8. Square root of 7/8 squared is 7/8. So sine alpha equals 1 minus 7/8 is 1/8, so that's the square root of 1/8 plus or minus, which is plus or minus. That's a perfectly good answer, by the way. Plus or minus, square root of 1 is 1, and then square root of 8 can be written as 2 root 2. Again, alpha is acute. Acute is between 0 and 90. Sine is positive. So our final answer is equal to square root, well, let's do 1 over square root 8, which is fine, or 1 over 2 root 2. All right, next example. Use an appropriate double angle formula to simplify. All right, we got to think a little bit here. 3 sine theta cosine theta. Okay, we got to take a close look at this. I'm going to write this. Well, the only thing where I have sine theta cosine theta is right here. Okay, I know that sine, let me write it right here, sine 2 theta is equal to 2 sine theta cosine theta. So how can I work 3 sine theta cosine theta to be somewhere in the ballpark here, or to be equivalent? How can I rewrite it? Well, isn't 3 sine theta cosine theta equivalent to 3 halves 2 sine theta cosine theta? Think about that for a second. The 2's cancel, right? The 2's cancel, and I still have 3 sine theta. If I went boom, boom, it's still 3 sine theta cosine theta. Okay, so it's equivalent. Why did I do that? Well, I needed to isolate the 2 sine theta cosine theta because that's what I have here. Okay, but it's multiplied by 3 halves. So let's think about this. If I multiply this side by 3 halves and this side by 3 halves, isn't that equivalent? I did the same thing to both sides of the equation. Okay, well now on this side I have 3 halves times 2 sine theta cosine theta. Well, that is equivalent to 3 halves sine 2 theta. So that's equal to 3 halves sine of 2 theta. And sometimes you have to figure out these manipulations to be able to solve more complicated problems. Last example, let's take a look at part B. We want to simplify this. 4 cosine squared of 2b minus 2. First thing I'm going to do is factor out a 2. So that would be 2 times 2 cosine squared 2b minus 1. Okay, 2 times 2 is 4. 2 times negative 1 is 2. All is good. Now, we have something real close to this. We have 2 cosine theta minus 2 cosine squared theta minus 1. So we know that cosine 2 theta is equal to 2 cosine squared theta minus 1. Well, this actually is equivalent here. I got a 2 here, a 2 here. I have a cosine squared, cosine squared. I have an argument here and an argument here. I have theta and 2b, and I have minus 1. So if we let or think of theta being equal to 2b, we're in business, right? If theta is equal to 2b, then this is instead of cosine 2 theta, I have cosine of 2 times 2b is equal to 2 cosine squared of 2b minus 1. All I did is replace theta with 2b. That's it. Theta is a placeholder. It could be anything. It could be triangle. It could be dinosaur. It could be x. It could be 374y. It doesn't matter. It's just a placeholder. In this case, I needed it to be 2b. So look, I have the exact same thing here. I have 2 cosine squared 2b minus 1. 2 cosine squared 2b minus 1. That is equal to cosine of 2 times 2b. So I can substitute this for this, and I end up with this 2 isn't going anywhere, times cosine 2 times 2b. And I really don't need these parentheses. I could write this as 2 cosine of 2 times 2b. And again, you have to look at these things. You have to be able to substitute, manipulate, use some algebra to make things a little simpler, or perhaps just in the form that is best to help you solve an equation or answer a question. All right, with that, I am out. I enjoyed it. I know you did. So there we go. Finish up with some Neil Diamond, Coming to America.